The Huisman Knowledge Management Project by Alvin, Andrew, DP, and Nufar. Huisman is a private company founded in 1929 in the Netherlands by Mr. M. M. Huisman. Originally a construction company for steel structures, Huisman now specializes in the design and manufacturing of heavy offshore equipment, such as heavy lift cranes, drilling equipment, and pipe-lay systems. Huisman is widely known for producing high-tech and innovative solutions for the world's leading offshore companies. Here is the organization structure of Huisman. As one can see, certain functions are centralized, such as finance, human resources, estimating, sales, and R&D. The other functions, such as engineering, production, and testing, are organized according to geographic division. In addition, the project management function is integrated within these divisions. The last division is Huisman Global Services, which is organized according to geographic region as well. As of 2014, Huisman has 3,500 employees worldwide, spread across countries such as the Netherlands, the United States, Brazil, China, Czech Republic, and Singapore. Each strategic location has one or more specialized functions, such as a local sales office, global services, or production facility. Since joining with engineering company iTrek, Huisman develops products 100% in-house, from concept to installation. Huisman's product range is subdivided into 6 main categories, which are cranes, pipe-lay equipment, drilling equipment, winches, vessel designs, and special projects such as standalone components and highly engineered integrated systems. In addition to creating innovative products, Huisman also provides a complete solution for clients that encompasses design and engineering expertise, production, testing, commissioning, and installation. A dedicated worldwide operating service team is on standby to provide advice, training, and service support before, during, and after installation and delivery. Huisman also has the Huisman Academy, which provides client employees with training in the operation and maintenance of equipment in the most effective and safe way. Over the last 10 years, Huisman has experienced explosive growth, growing from a 250-employee company in 2005 to having more than 3,500 employees in 2014. Although Huisman has been staying competitive in terms of providing innovative solutions, the same is not said about their internal processes, especially in the realm of IT systems. This growth in employees and products demands robust and integrated IT systems that can support the business. This is an overview of what the rest of the presentation will cover. We will define the specific problem in question, provide some context and scope, and state the requirements of the IT solution. After doing so, we will review 3 possible alternatives and consequently perform an analysis and decide on one solution. Lastly, we will discuss the implementation of the chosen solution. As Huisman's products are of extremely high value and their services are knowledge-intensive, there needs to be a system of disseminating relevant knowledge to not only the different functional departments, but also across the globe. With that said, the functions within the organization are largely isolated, with no proper engineering process and tracking. Because a central repository doesn't exist for information such as engineering data, projects, and documentation of engineering changes, the organization relies heavily on manual communication and updates. which often take a lot of effort and as a result may not always be done. As a result, this inefficient means of communication leads to duplication of work and unnecessarily interface documents between departments. As design and engineering are Huisman's distinct competitive advantages, a timely solution to this problem is necessary. Since this IT project is primarily concerned with design and engineering knowledge, the scope will be limited to only the relevant departments as shown. The ideal location for running a pilot for this IT project is at the headquarters in the Netherlands, where all the aforementioned departments are present. This solution will be developed with scalability in mind in order to be easily disseminated to the other locations around the globe. Currently at Huisman, design knowledge is unorganized and stored in different ways that are often non-searchable and non-automated. Microsoft SharePoint had been used in the past to archive information. However, this attempt failed due to a few reasons such as a lack of senior management support, which led to no proper company-wide implementation plan. This lack of support and unclear guidance led to fragmentation in the way SharePoint was used in the different departments across the different locations. This led to a solution that did not bring much value. The following are the list of requirements for the IT solution that is to be implemented. With the implementation of the IT solution, whether it is developed in-house or proprietary off-the-shelf, Huisman will be able to save time, cut costs, and ultimately deliver more value to clients. These expected results can be categorized into four main areas. One is instant availability of the as-built designs for existing systems. This is so that there is no confusion in the latest model revision of a spare part when it is ordered, as well as streamlining customer service when technical questions about client systems need to be answered. Another area is design improvements that are done on similar systems will be known instantly. This will result in the immediate availability for improvements to be made on systems still in the design or production phase, ending up in less drawing revisions and less warranty claims, as design issues will be known immediately before the systems leave the factory. Thirdly, the latest up-to-date knowledge can be easily collected in a timely fashion, cutting down on redundant research and meetings for project initiation. And lastly, with all engineering data available to all the relevant departments, this will facilitate more efficient interdepartmental cooperation and communication. In solving this problem, Huisman is faced with three options and two solutions. The first is developing an in-house software that is highly customized to fit Huisman's needs. The second is an off-the-shelf software that manages product lifecycle. And thirdly, there is the option of doing nothing, which isn't a solution to the problem. The first option is developing an in-house software that would address all the requirements of the project. As Huisman currently does not have an IT function, this would require hiring of IT professionals and consultants. This means huge upfront costs and a huge commitment in terms of time and resources. However, this solution would be highly customized to fit the exact needs of Huisman, offering them a distinct competitive advantage over their competitors. The next option is integrating an off-the-shelf software such as PLM, which stands for Product Lifecycle Management. Though this is a standardized software, minor customizations may be made to fit Huisman's specific business needs. However, Huisman employees will not be able to modify the software themselves, translating into less flexibility. Integration of this software will be done by the vendor. Therefore, unlike the first option, Huisman will not need to hire a specialized IT team. This option is especially attractive due to the minimal requirements in terms of resources, money, and time. Of course, there is always the option of doing nothing. This is undoubtedly the simplest solution. However, it comes with the potential to be the riskiest, as Huisman's competitors are likely to adapt and gain competitive advantages through IT solutions. We will pit the two actionable solutions head-to-head in 8 different categories. We will decide the winner of each category as well as the importance of the category in making the final decision. As both in-house and PLM solutions will address all business requirements, this results in a tie. In terms of flexibility, the in-house solution is a clear winner, as it can be constantly reworked to fit the changing needs of the business. As the Huisman business model is not expected to change much, this results in a low relative importance. Since the in-house solution is completely custom-made, integration of it within Huisman will be easy compared to the PLM solution. This is of medium importance. The next category is a tie, as both solutions give Huisman a competitive advantage over their competitors. Since the PLM solution is implemented by the vendor, there will be minimal IT infrastructure setup compared to the huge upfront costs that will be incurred by the in-house solution. To Huisman, without an existing IT department, this is of medium importance in choosing the solution. The PLM solution does not require any technical proficiency on the part of Huisman. As discussed previously, this is an important factor and is rated as high in importance. The PLM solution also wins in the last 2 important categories of time and cost. Overall, the clear winner is the off-the-shelf PLM solution. Due to the lack of existing IT expertise, the PLM solution makes the most sense to Huisman. The PLM solution provides an integrated platform with a single source of all product-related information that is needed for collaboration across the value chain. In addition, it supports processes such as product innovation, design and engineering, quality and maintenance management, and control of environmental issues. The 3 main areas of solution are in document management, CAD integration, and engineering change management. Within PLM, document management will address the digitization of paper trail, including design drawings, establishing a digital secured storage vault as opposed to multiple physical repositories, fast search query results based on attribute searching, workflow-based collaboration, IP protection, and compliance and auditing. With PLM, integration of CAD and business systems can be possible from a holistic, process-oriented standpoint. Bidirectional exchange of metadata from CAD files will be possible, as well as the management of CAD file relations, storage of CAD files in distributed content and cache servers, and communication of the CAD system directly with the PLM. Lastly, PLM will provide Huisman with flexibility, transparency, efficiency, and the integration with controlling and documenting engineering changes. As this PLM software is purchased from a vendor, integration of it within Huisman's internal systems as well as migration of data onto the PLM system will be of high importance. This includes testing of data from various interfaces, interface connectivity testing, as well as validating data that is displayed. Implementation of the PLM solution will be split up into 3 phases. The first phase is focused on migration of data from existing systems onto the PLM. This includes data such as archived projects, engineering change notices, and other critical engineering data. The second phase is concerned with onboarding of all headquarters departments and their users onto the PLM system. Lastly, the third phase is the complete rollout of the PLM solution to the global Huisman network. With any project, certain risks will have to be taken into account, as well as steps to mitigate those risks. One risk is insufficient project sponsorship from senior management. Without proper buy-in from the top level, it is hard for the PLM deployment to be successful. This has a medium probability of occurrence, and to mitigate this, a sound business case should be presented to top-level management, complete with tangible benefits and ROI. Another risk is the inefficient setup of the IT infrastructure that will host the PLM product. This will delay the implementation of the PLM software as a solution. Since the probability of this occurring is medium, the IT infrastructure setup needs to be expedited. Third, there is risk in training of Huisman employees and users on using the PLM software. Since people are often resistant to change, the adoption rate may be slow, impacting overall efficiency for a period of time. This has a high probability of occurrence, so PLM product training needs to be arranged as soon as the decision to go through with the project has been made. Thank you for watching.